Here's the solution video for the long answer problem. The first thing we want to do is we want to find the acceleration of the box. Um, and in order to do that, what you're going to have to do is you're just going to have to look at the net forces. And so as you can see on this image here, the gravitational force is totally canceled out by the normal force. And so you should get a net force of 0 up and down. But we have a frictional force here of 5 newtons, and we don't have anything on the other side to combat that. So my F net here is going to be 5 newtons. And in order to figure out how much the box is accelerating, what we need to do is we need to apply Newton's second law here. So we know the net force here is 5 newtons, and we also know that F equals m times A. And if we want to find A, we're going to use some algebra, divide both sides by what you want to get rid of on that side. So I'm going to divide by m. So I have 5 over m is equal to A. And the key here is that the mass of the box is 1 kilogram. So we have A is equal, I'm just rewriting it, to 5 over 1. And so, on the test, I'd put meters per second. Oops, I don't want to paste that, sorry. Per second squared. And as you can see in the problem, when you read it, it says round to the nearest ones place and do not add units. The reason why I don't want you to add units is that it's going to be hard for the program to read it. So on the test, I want you to write units, but for now, I want you just to write the number 5. Which description most accurately matches the force diagram above? And this is really important to me because I want you to be able to look at these things and describe what's going on. And so I'm just going to go through these one by one and just see, I'm just kind of talk about each of these because they're all really good answers, but only one of these is actually correct here. The object is moving to the left. That is a really big misconception. If you have a force to the left, it doesn't actually necessarily mean that it's moving to the left. It could be moving to the left, but it just is saying that the object is accelerating to the left if the net force is to the left. So on that one, we can't say that for sure. It doesn't always apply. If the net force is to the left, it doesn't always have to be moving to the left. The object is slowing down. And that one, we would have to have a little bit more information to know. We don't even know if this object right now is necessarily moving. We know there's a force of 5 newtons on it, but we don't know the velocity of the object, so we're not able to answer that. The object is speeding up. For that one, again, we don't know how the object is moving, so that one can't be answered as well. But we do know the object is accelerating to the left, so that is the best answer of those ones. We know for sure just by looking at where the net force always points in the same direction as it is accelerating. So if the net force is to the left, it's accelerating to the left. If the net force is up, it's accelerating upwards. I hope this was helpful.